Good day, everyone. I am Haname D. Kusai from BSEE2B, and today I'm going to show you how to solve a practice problem 3.5 in task 2. And the question is, calculate the mesh currents I1 and I2 of the circuit of figure 3.19. So this is the figure 3.19. So this is the mesh current. This is the loop number 1 and loop number 2. And let's start using KVL at loop 1. So KVL at first loop or I1. So KVL said that the sum of voltage in a loop is equal to 0. And we start from this voltage source here, and the current is flowing from negative to positive. So the sign will be negative. So we will have negative and the value is 50 volt, and then plus this is 4 ohm resistor. So 4, but to get voltage we need to multiply it by I1 because it is the only current that pass through this resistor. And then we move on to this 18 ohm resistor, and because we are working on loop I1, so I1 comes first, and then here we have I2 flowing to the opposite directions minus I2, and then for the last component we have this 6 ohm resistor, but to get voltage we need to multiply it by I1. So we will have all of this equal to 0. And let's do some algebra here. Negative 50 plus for I1 we have 4 plus 18, it's 22. 22 plus 6, which is 21 I1, and then for I2 I only have this value here minus 18 I2, and that equal to 0. Let's move this negative 50 to right side, so we will have 28 I1 minus 18 I2, that will equal to 0. Okay, let's save this as equation number 1, and let's move on to loop number 2. So we will have KVL at loop number 2, and KVL said that the sum of voltage in a loop will equal to 0. And we start from this voltage source here, and the current is flowing from positive to negative. So the sign will be positive, and the value is 36. And we move on to this 6 ohm resistor, and we need to multiply it by the current that passed through it, which is only I2. And then we move on to this 18 ohm resistor, because we know that we now working at loop 2, so I2 come first, but here I1 is flowing to the opposite direction, so minus I1. And then the last component is this 12 ohm resistor, so 12, but we need to multiply it by the current that pass through it, which is only I2, and that will equal to 0. And then again, let's do some algebra here. We have 36, and for I1 we only have this minus 18 I1 for the coefficient, and then for I2 we have 6 plus 8, which is 24. So 24 plus 12, it is 36 I2, and that will equal to 0. And let's rewrite this as 18 I1 minus 36 I2 will equal to 36. Let's have this as equation number 2. So now we can do something to solve these two equations with two variables, which is exactly what we are going to do. we are going to use elimination from the equation 1 and 2. So I will multiply the first equation by 2. Why? Because we will get this as minus 18 that will cancel with this 1. So we will have equation number 1 multiplied by 2. So we will have 56I1 because 2 times 28 is equal to 56, and then minus 36I2 will equal to 100. So this is equation number 1, and for equation number 2, we will just leave it alone. So we multiply it by 1. So we will have 18I1 minus 36I2, and that will equal to 36. Then we can subtract this. So this will cancel each other, and for I1 we get 38I1, and that will equal to 64. And what does this tell is 64 divided by 38 is 1.684 ampere. So I1 is equals to 1.684 ampere. And from here, we can substitute I1 to either equation number 1 or equation number 2. Okay, let's try equation number 2 then. 18 multiplied by 1.684 minus 36I2, that will equal to 36. And 18 multiplied by 1.684 is 30.312, and then minus 36I2 is equals to 36. And this makes 36I2 is equal to 36 minus 30.312, and 36 minus 30.312 is equal to 5.688. So I2 is 5.688 divided by 36, which is 0.158. So the answer to this question is I1 is 1.684 ampere, and then I2 is 0.158 ampere, and that's the answer of the question.